So this is problem 34 of chapter 8 of Giancoli 6th edition. So we have a grinding wheel, which is a uniform cylinder. The radius of this grinding wheel is given, and also the mass of this grinding wheel of this uniform cylinder. So with that, we can find the moment of inertia. The moment of inertia of a cylinder is just half of mr squared. And then comes question B. Question B is, what is the applied torque? So we want to know what is the applied torque necessary to accelerate this wheel from rest. So this the initial frequency is 0 all the way to a new frequency, which is given to us, and this frequency is given in RPM. So a good idea is to convert it to revolutions per second. And they want this change in frequency to occur in a certain time, delta t, which is given to us, and this time is in seconds. But careful, don't rush into solving this problem, because they also give us more information. They say that this wheel is known to slow down. So if it's led by itself, it slows down from an initial frequency to 0 in a certain time that is also given to us. And again, the frequency is in RPM and the delta t is in seconds, so careful with the units. So if it's known to slow down, if it's led by itself, that means that we don't have only applied forces in this problem, we also have friction involved. Okay, so the torque that causes the acceleration is the net torque, not the applied torque. Okay, so repeating, the torque that will take us from 0 to that final frequency is not the applied torque, but is the net torque. The net torque is the applied one minus the friction torque. Okay, so let's try to find what is the friction torque and what is the net torque. If we find both, then we will be able to find our unknown, which is this one. That's the question of the problem. What is the applied torque? To find the friction torque, what we need is the moment of inertia, which we already have, and the acceleration. The acceleration we can find because we have the two frequencies and we have the delta t. So we find the acceleration using the final angular velocity minus the initial divided by this delta t. And remember that the angular velocity is 2 pi frequency, the final, and the initial is 2 pi initial frequency divided by delta t. So with that, we can find the acceleration associated with the friction torque. Let's come to the net torque. The net torque we can also find using the same pieces of information. The net torque we can compute by using the moment of inertia and the acceleration. The acceleration here will be obtained from these two frequencies, therefore these two angular velocities and the time. Once I have the net torque and the friction torque, we'll then be able to find the applied torque.